Hello everyone and welcome to Azam Sharp Weekly, and this particular video is brought to you by my brand new course Introduction to Server-Driven UI in iOS, Swift and SwiftUI. This course is going to teach you how you can create your iOS application which is based on the principles of server-driven UI, meaning that you can change the complete interface of your application just by changing the response from the server. This means that you won't really require any app review and all the apps will be updated instantly. So this course is a very good introduction to how you can get started with server-driven UI. If you want to learn more about server-driven UI, check out the YouTube description and you will find the link to purchase this course. Thank you so much, and I really hope that you enjoy this video. Alright, so now let's go ahead and talk about what is a server-driven UI. But before we dive into server-driven UI, we need to understand what is non-server-driven UI. And that is very common because we have been doing that for a very long time. In a non-server-driven UI, we will start with the client, which in this case will be an iPhone. We will also have a server. The client is going to make a request to the server. The server is going to give some sort of a response back to the client. Now, the important part over here is that what does that response looks like? The server is going to be simply sending the client the data that the client needs to display. In this case, it is name, image URL, and description. Once we get that data will eventually be displayed onto the client. The image may be represented by an async image view or some sort of an image view. The name will be represented by some sort of a text as well as a description. So in this case, the server is actually sending you the data, and that data is presented on the client. But the client is still responsible for coding up all the interface, meaning all the logic of consuming data and also creating those controls, structuring those controls is still on the client side. So client is still responsible for creating the interface based on the data that it receives. But if I want to put the image at the end, meaning at the bottom, and the name and the description on the top, I have to update the client. I have to send another version to the App Store, and the user has to download the different version. This is where server-driven UI is a bit different. Some of the things are still same. You still have a client, which in this case is an iOS app, and you still have a server, and the client will still make the request, and the server will still respond with some sort of a JSON. But that is where it changes. The response that you're going to receive from the server in a server-driven UI will not only contain the data, but it will also contain that what components, views that you want to display. And that's the important part, because the server is dictating to the client that how and what components it needs to render. This means that if we get a response like this from the server, we can use it to create an interface which consists of an image and two text views. The featured image component on the top will be responsible for creating the image. The text row will be responsible for creating a text to identify and present a name. We can have another text row which can be used to present another text. And that's the power of server-driven UI, because your server is not only sending the data, but it is also sending which components you want to display. In this example, you can see that now we have changed the featured image. The position of the featured image is now at the bottom of the response. And that is why you can see that featured image is now at the bottom. This change was made on the server. The server simply changed the structure of the JSON sent to the client, and the client never had to be updated. it was instantly updated and it was instantly shown that now the featured image should not be on the top, but it should be at the bottom. So you don't really have to even push a new version of the App Store to make that change. You can simply change the response sent from the server, and that will allow the client, meaning your iPhone app, to be different, to be changed. So now that you understand what exactly is server-driven UI, let's go ahead and take a look at some of the benefits you will receive from server-driven UI. All right, so now let's go ahead and talk about some of the benefits of server-driven UI. One of the biggest benefits of server-driven UI is the ability to change the user interface without going through the app review. If you want to change something in your user interface without the server-driven UI, you have to make the change. You have to submit the binary. Now it will go through the whole process of the review. It might take a couple of days, and then it will be deployed or will be available for the users. But in a server-driven UI, you can simply change the JSON that you're returning, and since the whole interface is controlled by the JSON, you can simply change the user interface provided that the components that you are targeting in your JSON already exist in the binary that is available on the App Store. All right. Now you can also change the structure, change the ordering of the actual interface. If you want the image to be at the bottom, you can put a featured image at the bottom. If you want the rating to be at the top, you put the ratings control or a component on the top. That is great, and that allows you to change the interface instantly. Another great benefit of server-driven UI is that you can instantly update on multiple platforms. So if you are targeting your app for iOS, Android, and web, and all of them are reading from the same JSON, all of them are using server-driven UI, then once you change the JSON, it will automatically update on all the platforms. And all the platforms will be sync with each other, and they will reflect the changes. Now, one of the common questions people ask is that, hey, is that even allowed to do server-driven UI? What about if Apple will say, hey, you can't do that, what are you doing? This is perfectly fine. A lot of companies are doing it. Airbnb, you have Uber, and a lot of different Spotify. A lot of companies are doing it. There's nothing wrong with server-driven UI. You're not really changing the logic of your application. You are simply rendering the controls, the components, which are already existing in the library. So it's not like you're doing any big change. You're simply saying, well, instead of the text rating control, I want to display this nice star rating control. And that's what you're doing basically. All right. And the other benefit that you get is you can easily perform A/B testing. Because A/B testing, you can simply go ahead and change your structure of your JSON, and now you are displaying a carousel instead of images. And you can easily A/B test without having to redeploy your apps. And with the actions that you will learn later on, you can completely change the navigation. Maybe you are currently saying that, hey, you will go from point A to point B, but if you want to go from point A to point Z, you can do that because all the navigation is also controlled by the server, by the JSON. You can also control the view presentations. Maybe currently you are displaying a particular view in a modal, in a sheet, but you're like, hey, I want to display it in a push navigation, so you can also do that. And that is all the great benefits of server-driven UI. All right, so now let's go ahead and talk about the core architecture of server-driven UI. In order to create a server-driven app, we're going to start with the server. That's a mandatory thing. You must have a server that can be implemented in Node, Express, Vapor. It can be Django. It can be ASP.NET, Ruby on Rails, Go, whatever you want. All right, so we have our server that's going to be returning you a JSON response. Now that response will be mapped to the UI models that we will create in our client, meaning the iPhone application. Later on, those UI models which will be representation of the JSON that you receive from the server, will be passed to components. Based on the type of the UI model, we will create a particular component. So if you're saying that, hey, I want to get a carousel, then we will map it to a carousel UI model and create a carousel component. The carousel component, the list component, the featured image component, the rating component, whatever component that you are trying to render will eventually render the view. And that is the architecture that we're going to be using for our server-driven UI. Starting with the server, sending the JSON back, mapping it to the UI models. UI models are passed to a particular component, and in the end, the component will be responsible for rendering a particular view. Let's go ahead and take a look at what you will be building in this course. So this is our pets application. You can see that we have a featured image on the top, we have a carousel also, and we have a list. I can click on one of these carousel items and go to the details screen, which will display the image, description of the pet, and also the rating. I can also go over here and click on any one of these and go to the same exact thing. Now, all of this is controlled by server-driven UI. This means that if I want to change some aspects of it, meaning if I don't want to display the carousel anymore, all I have to do is I can simply go to my server and remove the carousel part. And now the user can run the application again, and they will not see the carousel. Let's go back to our app, and now you can see the carousel is gone. Just by changing the response, we were able to simply hide the carousel or not even display the carousel. Now, if we want to even change our list, meaning these items, and we don't want to display the description part, we can even do that. Let's go and find out where in our server is that being managed. If you go to our server, we can see that we have a description over here. We can simply go ahead and remove this description from both the items. So this description cell is now no longer being displayed. Now let's go back, and you can see the description is gone. Now maybe you want to add a carousel right over here. Well, again, we can always go back and add our carousel using the server-driven UI, meaning we will simply go and change our JSON, and that will allow us to create a carousel. So let's go ahead and add the carousel. We will find the list, and since we want to put the carousel after the list, we will simply go ahead and add the carousel. Now, if I go ahead and run the iPhone application again, I should be able to see the carousel underneath the list. And here we go. You can see that now we have a featured image, we have our list, and underneath the list, we have our carousel. So we were able to change the UI just by changing the JSON. We didn't really have to submit a new version of the app to the App Store. We didn't really have to do anything. Just changing the JSON that is being returned to the iOS app allowed us to change the look and feel of it. And that is the server-driven UI, and that is what you will be learning in this course. All right, everyone. So now that you understand my reasoning behind selecting Node and Express instead of Vapor, let's go ahead and get started. The first thing you need to do is to download and install Node. So you can simply go to nodejs.org, as you can see, and download and install Node. Super easy, right? Once you download the 16.14.0 or whatever the latest version is, double click on it to install it. Now, if you plan that I don't want to use Node, then I'm also going to show you a way that you can write JSON into your file and read it from there. But obviously, in an actual application, you do have to host your JSON somewhere. So Node is an option or you can use some other server. That's perfectly fine too. I have already installed Node, so I can simply go ahead and start creating my server. I'm going to start with calling it mkdir, make directory, and I'm just going to say pets server. Let's go ahead and jump into the directory. I have already installed Node, so now I can simply say npm init, Node Package Manager init, which is going to initialize my pet server folder as my Node project. When you run npm init, it is going to ask you different questions like, hey, what's the name of the package name? What's the name of the version? What's the description? And all that stuff. We can simply go ahead and go through all of that stuff just by pressing the return key. Now, you can go ahead and open Pets Server project into your favorite editor. I'm just going to open it up in VS Code, but this can be any different editor that you plan to use. Now, over here in your project, what I want to do is to add a new file, and I will call it app.js. And I'm adding the app.js because this will be our main file where we will run the server, we will write the code. Go to packet.json and also make sure that your main file is now app.js. Now, technically, you don't really have to do it, but I have a habit of creating app.js file instead of index.js. So that's why I'm just renaming it to app.js. Let's go to the app.js. Currently, you can see in app.js, I have nothing over here. I'm going to go ahead and open up the terminal. The terminal already knows that which folder you are inside, so it's going to open up the current folder of the Node project, which is called Pet Server. Perfect. Now, in order to run a server using Node, we have multiple options. We can just use plain vanilla Node, and that will work fine. But in order to create a server, we can also use the power of Express.js, which allows you to create a server very easily. You can always go to Express.js website and check out all of these things. This is a very fast, opinionated minimalist web framework for Node.js. So it's very easy to build a server in Express. The first thing we need to do is to install Express package. So npm install Express. Pretty simple. This has been installed. You can always check what servers, what packages that you have installed, and you can see the Express is under the dependencies, indicating that the Express package has been installed. There can be many different packages for databases, for security, authentication, and all that stuff. But right now, our app, our project, Pet Server, only depends on one package, which is Express. The next thing that we want to do is we want to make sure that we are writing code to start our server. So I'm just going to go ahead and say constant express equals to require express. Now this is all JavaScript code. So what this is going to do is whatever is being exported from the Express package, we are going to import it, and now the Express variable contains all the different functions and everything that is required to create our application. App equals to express, it's a function, we call that function, and that's pretty much it. Now we can go ahead and run our server. We will run our server on port number 3000. It's going to fire a closure, and inside this closure, we can say server is running. And that's it. That's all the code you need to start a server. Now, currently, we have started the server, or we have created or built the application that will start the server. Let's go ahead and run our application. In order to run our application, which basically consists of all of this code, we will simply say node and the file that you want to run. The file that you want to run is app.js. So let's go ahead and say app.js. You can see that when we run app.js, it simply executes this line and it says that the server is running. Okay, so if the server is running, what happens if we go to localhost 3000? Let's go to localhost 3000, and it simply says nothing. It says cannot get, and then this kind of like a root URL. The reason it is telling you that cannot get is because it just doesn't know what to do when you go to localhost 3000, which is the root URL of your application. In order to do that, and in order to make changes, what I'm going to do is press Control-C to stop the server. Now I can go ahead and make those changes. So app.get root URL. And if you go to the root URL, I want to respond, I want to send you some JSON with a message which is saying hello world. Okay? So this means that when you actually go to the URL, which is localhost 3000, then it is going to execute this code and it's going to return you message which is an object which will consist of the message property, and the value will be hello world. Let's go ahead and run our server again, node app.js. And this time we're again going to try to go to the root URL. And now you can see that when we go to the root URL, it actually returns you a message, and that basically is simply saying hello world. Pretty cool, right? So this is all the code that we need to write to return something as JSON in our Node Express application. Now, obviously, we don't really want to return hello world. What we want to return is some sort of a template that can be used with our iOS application, and that will help us dynamically create the UI based on the server's response. So let's go ahead and do that in the next lecture. All right, everyone. So now that we have been able to run the server, we can also return JSON. The next task for us would be to return correct JSON so we can represent the featured image. So basically, we're trying to create a page, a screen that looks kind of like this. And currently, we are only focused on the first component, which is the featured image. So this means that our JSON that we will be returning from our server should represent a component featured image. And then later on, we will add the carousel. Later on, we will add the list and so on. All right. So let's go back. And first of all, we need to create a better URL, not like the root URL. Maybe we should create a URL that will indicate that we are trying to get the pets listing. So let's go ahead and say that that particular URL will be called pet listings. So let's go ahead and change it over here, pet listings. Okay, so now we can construct what do we want to return, the UI model, the response that we want to return. So I'm going to go ahead and create a model, which is an object. The model can have many different properties. We are going to arrange it as we have learned earlier. Our model will consist of the page title. This can be any page title, so I'm just going to say pets. And it will have components. And it will be an array. Now, why am I returning an array of components? Well, if you look over here in the diagram, you can see that we have three different components. This is just the first component. Carousel is the second component. And list is the third component. So we actually have three different components that we want to return to the client. But right now, we're only focused on the first one. We're only focused on the featured image. But we are still going to use an array of components so that later on, we can add more components. So that's why we're returning an array of components, the components that we want to display on the screen. Okay, so we have created the array. In the array, we will have an object. And now the first property we're going to use is a type. What type of the component we're returning? Well, we're returning this component right here. So what will be the type of this component? Now, this type is obviously based on what you want to call this. I'm just going to say featured pet, I guess. That's fine. Featured pet. You can also call it featured image if you want to, but I'm just going to call it featured pet, featured image. I mean, you can use anything you want, featured image, hero image, whatever you want to call it. That's fine. And then what will be the data associated with that particular type? In order for us to display an image, what do we need? Well, in order to display an image, we need the URL of the image that we want to display. So we will have the property called image URL. And now we need a URL of an actual image. So I'm just going to paste it right here. There we go. And that's it. We have created a model, and now we can go ahead and return the model as JSON by simply saying response.json, and we're going to return the model. Now you might be thinking, hold on a second, where did you get all of this stuff? Like, where is the image coming from and all that stuff? Now, there are many different ways of doing that. It can come from some sort of a server file that you're maintaining, like a JSON file. It can even come, from the database. So in your database, you will have the image URLs that you are storing, and you are basically returning all of those image URLs and compiling the data part of it. All right? So there are many different ways that you can get all of this stuff. But we're going to start with kind of like hard coding the stuff. And then later on, we can probably create some sort of a small array related database that we can do. But the important part is that you're returning a particular template that you know what exactly fields you're returning, and you have talked to the client, meaning talk to the iOS people, talk to the Android, talk to the web people, and all of your team have agreed on this particular model. Because one of the great benefits, as explained earlier, is that the same exact model, the same exact response can be utilized by many different platforms. All right, before running this, let's just go ahead and make sure that we call it pet listing, not listings. It's just listings is already kind of like indicating that it's going to be a list. So make sure you update it to pet listing. Okay. Now, with the changes done, and let's go ahead and run our server, and hopefully we can go ahead and check it out. There we go. So if we go to localhost 3000 pet listing, you can actually see that the page title is pets. We are returning a JSON. That's great. And the type is featured image. That's the name of the component we want to render. And we're also providing the data to that component, which is image URL. And that image is coming from Unsplash. The credits should be in the second lecture of the course, where I gave all the credits to all the images that I've used. So now our server is actually returning something. Now it's up to the client, the iOS app, to take this information and to render a particular component called featured image component and display the image. All right. So now we have to go and create our iOS application. So let's go ahead and get started with that in the next lecture. All right, everyone. So our server is now returning a response for a pet listing page, pet listing screen, which will eventually have the carousel and the list, but we're starting out small. So we currently have only featured image. All right. And this is eventually how it will look like. So currently we're only working on the featured image, but eventually it will have the carousel and it will have the list. Okay. I've already created a basic SwiftUI application, and currently it doesn't really have any code. So let's go ahead and get started. And what we're going to do is we are going to be implementing our web service. So I'm just going to go ahead and create a new folder called services. I'm going to go ahead and add a new file. I will call it web service. Okay. So in the web service, what we're going to do is we are going to be reading the information from this URL. All right. So we'll create a class called web service. And in this web service, we'll have one function, and I'm just going to call it load. There we go. But the problem now is that load what? Like what kind of a resource we're trying to load, what kind of a screen, what kind of URL that we need to pass in, right? So over here, I'm just going to say that this will be something called a resource. So I'm just going to go ahead and add a resource over here. And this can be string, that's fine. I mean, all of this can be actually in a constant. So let's go and actually move it into a constant. All right. So I'm going to go over here into a new group. I will call this group utils. And we will go ahead and create a new file. And we will call it constants dot Swift, or it will already be Swift. Okay. Now we can go ahead and say constants. Okay. And we need to make sure that we are providing constants for the URL, right? So I'm just going to go ahead and create an internal structure, URLs. And in there, I can go ahead and say pet listing. And this pet listing can contain or can be something like pet listing. I mean, that's basically what the URL is. All right. The other thing that we can use is kind of like the base URL. So if you want, you can go ahead and also create a base URL and you can assign it something. So in our case, the base URL, I'm simply going to assign the first part and change the pet listing with a slash. There we go. Now, if you're returning pet listing, probably we should be adding the base URL with it, right? So let's go ahead and append the base URL so that we have the complete thing. There we go. Base URL slash pet listing. So that will be the complete URL of our whatever the request that we're trying to make. Now let's go back to the web service. And over here we can say resource, whatever the URL, whatever the resource that you're trying to get, you need to pass that in. It will be async throws, and what we are going to return is the interesting part, because we are going to be returning some sort of a screen model, some sort of a template that we are going to map to. A template that can confirm this result, meaning a template which can be mapped to this result containing page title and components. All right, so right now, we're just going to remove that part for now because we don't really have a screen model, but we need to create the screen model, or else it's not really going to work, because we do need to have something that we need to return. All right. Next up, we're going to use URL session.shared.data, and we can use async and await. So I can simply pass in the URL to get the URL. I think another good thing we can also do is we can make sure that our constants, instead of returning you kind of like a string, is returning you a URL. So we can definitely accommodate that part also if you want to. Okay, so URL, that's perfectly fine. We're going to go ahead and create the URL over here. If you want to do that, you can do that. Here we go, URL, string, passing in the resource. If, however, this is not really working, then we can throw an error. And for error, I'm just going to go ahead and create a network error, which is error. And we can say invalid URL in this case. Throw network error.invalid URL. So something bad happens, then the URL is not really good, then we can throw the network error.invalid URL. Next, we can pass in the URL. We don't really need a delegate or anything like that. Try await. This is going to return us something like a data and a response, a tuple. Over here now we can check that if the response is good. So HTTP response equals to response as HTTP URL response. If that is good, then we are also going to get the check the status. All right, so we need to see HTTP status if that is 200. Else, if it's not, then we can go ahead and say a bad request or invalid server response, which is another case that we will need to add to our network error. So there we go. Okay, So now we have created the web service. Our web service doesn't really return anything. Let's go ahead and throw this error. Currently, it's not really doing much because it is making a request, but it is really not utilizing the response. It is not really utilizing the data. So now what we need is we need something that can take this data, all right? Something that the JSON can be decoded into. So that part we are going to be doing in the next lecture, where we will be introducing the screen model and also component model. So let's go ahead and see how we can create our models where the JSON will be mapped and populated. In the last section, we covered how we can start our own server using Node and Express, how we can return JSON template from the server, and we were implementing our web service, but now we require some sort of a model where we can map our JSON into. And currently, we don't have that model. Let's first go ahead and take a look at the response that we're receiving. So the response that we're receiving from the server, which is a template, it starts with a page title, and it has property called components, which is an array of different components. The only component currently that we have is a featured image component, which also has a data property, which is the image that we want to display. But if we go back to our iOS application, we don't have any model to map that JSON into. So let's go ahead and create our UI models. I'm going to go ahead and add a new group. I will call it UI models. And I'm going to go ahead and add something called a screen model. The screen model will represent the top part of our response. Screen model. Now looking over here, we need a page title. That's the first property that we need. We also need a property called components. So let's go ahead and do that. I will create screen model. It has to be decodable so that the JSON can be decoded into screen model. We will start with a page title. That's easy. That's just a string. And we will create a property called components. Now, the question is, what should we pass here in the components? Now, in the components, we have to pass something that consists of a type and a data. So let's go ahead and do that. Well, we don't have anything that has type and data. So this means that we can actually go ahead and create another struct that is going to represent the component. Now you can create it in a different file, but since they are kind of like very closely related, I'm just going to make it over here. Component model, decodable. We will have a type, which can be string, and we can have a data, which can be something. So right now, I'm just going to go ahead and say that the data is string and string. But eventually, we will have to change that because the data can be string and any. So right now, we're just going to go with string and string as a dictionary. So the string key can be image URL, and the string value of the dictionary can be the actual URL. Now we can go over here and we can say component model. All right. This means that this type property that we have in the component model is going to map to the type property over here. Now, since it's a type property and it is a string, maybe it's a good idea to expose our type property as some sort of an enum. So let's go ahead and create an enum. Enum component type. It will be string and decodable. And in this enum, we can go ahead and create our cases. Case, which is featured image. Because there is currently only one component type that we are assuming, which is featured image. Let's go ahead and build it. and make sure that this component type is now placed instead of the string. Perfect. So now we also have the component type. Now the next thing that we want to do is to create UI component. So right now, these are just used for decoding, but we still need to make sure that we are decoding our actual response. This means we can go back to our services, and now we can start using our new thing that we just created. So let's go back to the services, and we're going to go ahead and try to decode it to the screen model. Once we get the response and everything, we can use JSON decoder.decode, and we can decode our response to the screen model. So screen model.self and the data. We can go ahead and return whatever is being decoded. We need to update our definition of the function because currently it does not allow us to return anything. So let's go ahead and return something. All right. Now, whether you returned a screen model or something else, you just have to make sure that you are decoding it. Now, let's go ahead and try to build this. And we can see over here that this is still having some issues. So let's go ahead and tackle this part. We are getting the response, not resource. So that's our mistake. There we go. And now everything should work. This means that when we call the web service, it's going to create the request. It's going to call the load function, and it's going to get the URL from our, whatever the resource you're passing. And it's going to get the data and the response. And finally, it's going to decode the response to a screen model, which is a template, which is going to be used for every single page. All right. Now, currently, we have created these UI models, which is screen model, component model, but we don't really have any components right now. I mean, what will the featured image component look like and which view it will render? So let's go ahead. In the next lecture, we're going to work on adding our first featured image component. All right, so now let's go ahead and move to implementing our component. The basic idea of a component is that the component is going to take in the UI model that we will construct, and the component will be able to decide which view to render. But in order to create the component, and since we will have a lot of components, we will first start with creating a protocol for a component. So I'm going to go ahead and create a new group, and I will call it components. There we go. Inside this component, I can add a brand new file, and I will call it UI component. The UI component will act as a protocol, and using the UI component, we can create other components. So first, I'm going to go ahead and import SwiftUI protocol UI component. Now, in order to create the component, a component must have a couple of different things, like a unique ID of the component, which is only for getter, and a function render. And when a component calls a render function, it is going to return any view. Now you might be wondering, hold on, isn't this a bad practice to return any view? In this case, it's fine. We are not really doing anything that much with any view. We're just simply rendering any view, and that's it. So it's not really going to cause that much of a performance difference as compared to rendering some other views. Okay, so now we have created a UI component. That's just a protocol. Now we can go ahead and create a particular component that we want to render. So component will be the small pieces that will be rendered on the screen and that will actually show up. The one component that we want to create is the featured image component. And let's go ahead and add that. Okay, So the featured image component will use the UI component as a protocol. So first, let's go ahead and create our featured image component, which conforms to UI component. This means that the featured image component must implement a couple of different things: the unique ID and the render. Let's talk about unique ID. We need to return something like a unique ID for our featured image component. Now we can go ahead and probably say component type dot featured image, and we can say the raw value, and that should be okay. That's unique enough. For the render, we need to make sure that the featured image component is rendering kind of a view that you want to render. And this is kind of up to you. So let's start with this. Let's start with implementing or returning text, which is obviously not correct, but just to look at it out, component. So you can do it over here. And we need to make sure that we're returning any view, right? Okay, so let's go ahead and also import SwiftUI, because any view lives inside SwiftUI framework. So this is it. This is how you will create your components. All right. Now, a couple of things that are wrong with featured image component. The featured image component was supposed to display a featured image, but it's not really doing that, right? I mean, it's simply returning a text. In order to display an image, we need a couple of different things. The featured image component will rely on the properties of the UI model. Now, if we go back and look at the properties, you can see that we need the image URL for the featured image component. That's the data. And without that, we won't be able to do anything. So in order to do that, what I'm going to do is I'm going to go ahead and add a new file, and that will be the featured image UI model. Featured image UI model. Now you might be saying that, hold on a second, why are you creating featured image UI model? If it's simply an image URL, like a string that you want to pass in, why don't you just pass in that string? The reason that we're creating a separate file for a UI model for featured image is that it can easily grow in the future. So struct featured image UI model, which is decodable, let image URL, which is simply URL. Now you can call this URL, I guess, that's fine. There we go. Okay, so now we have created a featured image UI model, which contains the image URL, which is the only thing that your featured image component needs. So going back to the featured image component, now we can make sure that when you're creating the featured image component, you need to pass in a featured image UI model. All right. The final thing that is left to do is to actually create a particular view. Right now, you can see that we are returning a text view, which is not correct. We shouldn't be returning a text view, right? So what can we do in this case? Well, to start out, we can simply return any kind of a view that we want. In SwiftUI, you can use async image, and you can pass in the URL, which we already have now, UI model.image URL, and we will get the image in, and now we can go ahead and do the resizing on the image. We can also set the aspect ratio for the content fill. If we want to add like a placeholder or something, we can even do that. So placeholder, and for the progress view. So you can see that we can do a lot of different stuff. The only thing is that now we need to make sure that we are returning any view. In order to return any view, what we can do is we can make sure that we have some sort of components that are returning any view, some sort of an extension that is returning any view, because right now it's not returning any view. In our project, pets project, I'm going to go ahead and add extensions folder. This is just a helper extension that we are trying to build that will allow us to easily return any view. So view plus extensions. The first thing we're going to import is SwiftUI because I want to use any view. And then I'm going to create an extension on the view. And we will create a function called toAnyView. It's going to simply return any view. And that's it. We're just going to call any view, and whatever the control, whatever the view is calling this extension self, we're just going to return any view. Next, we're simply going to go over here and call toAnyView, which is going to indicate that now the async image, after downloading the image, it will be converted and returned as any view. So this is what our featured image component looks like. Now, if you want, you can move all of this into a separate view. You can call this a featured image view, and that is perfectly fine. If you want to do that, you are free to do that. That is perfectly fine. All right. Okay, so at this point, we have created our featured image component. We have rendered a particular view, which is just an image based on the URL that is provided by the featured image UI model. So each of the components will take a different UI model, which will provide the data to the component and eventually to the view. Now, the next step that we want to do is to actually write the code to make all these requests. And that is to be done inside a view model. So let's go to the next lecture and see how we can implement a view model. Now we need to implement a pet list view model, which is going to utilize the web service that we created, make a request, get all the JSON, map it to screen model, and then lay out the components. So I'm going to go ahead and create a new group, and I will call it view models. Inside view model, we're just going to go ahead and create a single view model. We'll call it pet list view model. Great. I can go ahead and say pet list view model, which is going to be using the observable object. Okay, so now we need to decide that how would we be creating this view model. In order for this view model to work, we need to pass in a web service. So I'm going to go ahead and say service, and this will be a web service. And I will go ahead and create an initializer where you can pass in the service, which is of type web service, and we can initialize it. There we go. In order for the view model to work, we also need to implement the load function. The load function's responsibility will be to actually load, call the actual web service, get the UI model, the screen model associated with the request, and then eventually display the components. We're going to go ahead and call service.load. This is our web service that we implemented earlier, and you can see that it is marked with async throws. This means that we can only call it when we are making sure that we're catching the exception. For the resource, I'm going to go ahead and pass in urls.petListing because we are trying to get the template for the pet listing page. Let's go ahead and wrap this around with a do. Make sure that we use try, and we can also catch. When we get an error, we'll just display it on the console for now. When we call the service.load function, it is going to return us the screen model. So we're going to capture the screen model. Now, we also need to make sure that we are using await because the service.load is an async function. After getting the screen model, we're not really doing anything. You can see the screen model can have components, the screen model can have page title, but we don't really do anything with the actual screen model. What we want to do is we want to go through all the different components and give us an array of components. Now, this can be done right over here, but it would be better if this is done somewhere else so we are not polluting our view model. So I'm going to jump into the screen model. You can see the screen model is a struct which only contains page title and components, but we can also add some other functions to it. So I'm just going to go ahead and add an extension to the screen model. And then we will go ahead and build components. So we're going to add a separate function, which is going to be called build components. And this is going to give us an array of UI components. So the whole purpose, the whole point of build component function is to construct the UI components and return it. Over here, we can go ahead and create a local property called components, which will be a UI component equals to an empty array. This will eventually be populated with all the components that we're trying to make. Now we can go ahead and say for component in self.components. So this is basically the components that we're getting from the server, and those are the components we're trying to build. We can perform a switch on the component type. And based on the component type, we only have one, which is featured image. Now we can go ahead and construct a UI model, which will be of type featured image UI model equals to component.data. You can see the data over here is string, but what we want is some way to convert this string to the featured image UI model. All right. Now we can do it over here, but it might be a better practice to create some sort of an extension that will help us decode. So we need to move and create that extension before we can do anything. So for now, I'm just going to go ahead and say featured image. And then just so that we are not causing any issues, I'm just going to go ahead and return components. All right. Okay. So now the problem is that we are causing over here, we are getting the UI model, but we need to construct a featured image UI model. What I'm going to do is I'm going to go to the extension. Let's just go ahead and open all of this up. And in the extension, I'm going to add another extension, which will allow us a helper function to decode. So I'm going to add a new file, and this extension will be built on the dictionary. So I'm just going to go ahead and dictionary plus extensions. This is just to help us out, and you'll see that it makes our life a little bit easier. The whole point of creating this extension is that so that we can easily decode a dictionary to a particular type. So we're going to go ahead and extend the dictionary. And in the dictionary, I'm going to go ahead and add a function called decode, which is going to work on a generic type conforming to decodables. All right. And this is going to return us the type that we are trying to get. Let's go ahead and now use it. So guard let data try JSON serialization dot data, and then we can take the actual self, which is an instance of a dictionary. Pretty printed is fine. Else, we're going to go ahead and return null. So if the decoding actually fails, we're going to return nil. If the decoding is successful, we can actually try to decode it. All right, so we can use JSON decoder dot decode the actual type that we want to decode, and the data is just the data. So this will hopefully help us to decode a little bit easier. Going back to our code now, in the screen model, we still need to implement our build component function. So once the component type is featured image, this is where we can construct a UI model which will represent the featured image UI model. And we can use component.data.decode, and decode is based on the type that we are giving over here. Since it's a generic type, we are using featured image UI model, which is decodable. If, however, it actually fails, then we can go ahead and throw some sort of an error. I'm just going to go ahead and say component error dot decoding error. Now, there is no such thing as component error. So that is something that we will have to create also. Let's go ahead and create component error, which is of type error. And we're going to just add one simple case, which is going to say decoding error, and that's it. Okay. So now at this point, we are taking control of when the type is featured image, then we will decode UI model. All right. And after decoding the actual model to the featured image UI model, what we want to do is to create a component. I mean, that was the whole point, right? So components dot append a new element, and we are going to append a featured image component, and we're going to pass in the UI model that we just decoded, which is of type featured image UI model, which contains all the stuff that the featured image component needs to build the component. Okay, so after that, we're going to go ahead and build the application, and now you can see it's successful. Let's go back to our pet view model, pet list view model. Once we get the screen model, we can go ahead and call screen model dot build components. This can blow up, so we're just going to call it with try. This is going to return us the components which we are not handling. So we need a property in our view model that can handle the components. So I'm just going to go ahead and say publish var components. And the reason that we are making it publish is that we want to make sure that when it is published, it will notify the view that it has been published, so the view can re-render itself. And then we can say self.components. We don't even need self. There we go. Okay. Now, another thing that we need to make sure is that everything that we are doing is basically done on the main thread. So I'm just going to go ahead and mark this with main actor, so that all the properties that we are setting, especially the components, since it's marked with publish, is actually assigned or set on the main thread. So that's why we are decorating it with main actor. Okay, so at this time, we have our pet list view model. We also have our load function. The final step that we want to do is to display the views on the screen. So let's go ahead and tackle that in the next lecture. All right, everyone. So now that we have our pet list view model, the next step for us would be to display all the different components, which we only have one, which is the featured component. So let's go back to the content view. In the content view, we can see that this is kind of like just the default code that we have. So the first thing we need to do is to create an instance of state object, or the pet list view model. So let's go ahead and do that. Private var VM, which will be pet list view model. We need to pass in the service, which for now, we're just going to pass in the web service, which is the actual service going to make a request and get us the actual, response from the server. Okay, so that's fine. The next step, what we want to do is we want to make sure that we are adding a navigation view. Eventually, we will need the navigation view, not really right now. Since we can have different components, multiple components, and it would be a good idea to use a scroll view. Next, we can use a for each VM, which is Viewmodel.components. So in this case, this will be populated with all the different components we have fetched from our resource. And if you look at our resource, you will see that the only component we have right now is only one, which is fetched or featured image. So we're going to go through all of these components. We're going to use a unique ID, which we already have, unique ID. We're going to get whole of the component, and then each component is conforming to the UI component, which means all of them will have the render function. So we're just going to call the render. And if you want to go ahead and add some navigation title and everything, you can do that for at least your home page. We still need to make sure that we are performing the request. So in the task, we can go ahead and perform vm.load. This is an async function. So in order to call that, we have to await for it. All right, so now let's go ahead and take a look at this warning a little bit closely. Now, if you are using a specific version of Xcode, then you will not get this warning. Let's go ahead and check out which version I'm using. And you can see that I'm using 13.3, which was just available a couple of days ago. But on 13.3, they introduced a couple of different things for the Swift language also. And one of those things is the expression that is requiring global actor cannot be appeared in the default value property of VM. This is an error in Swift 6. So basically, they're telling you that you can't do this as a property, which we're creating, which is a VM. And if you need to initialize this property, you should probably use underscore VM to initialize it and initialize it in a constructor. Okay, so how can we do that? Well, let's go ahead and remove some parts of it. So we're not really initializing the property, we're just creating the property. There we go. And now inside the initializer for the content view or any kind of a view, we can initialize it by saying state object, because this is a state object that you're trying to create. Passing in the wrap value, which is pet list view model, and then passing in the service. There we go. And now you can see that particular warning has now gone away. All right. And that's it. Let's go ahead and run our application and see if it works correctly or not. So I'm going to go ahead and simply launch the application. All right, so here it is, and it looks great. And these cats are really, really cute. You can see that our featured image is actually being displayed. So this is amazing. We have rendered this dynamically, meaning all of this interface is built using the server-side code. Now, a couple of different things you will notice right here on the console, on the output window, is a lot of breaking constraints error. Don't worry too much about it. This is SwiftUI just having some issues, having some bugs. We can turn it off. Let's go to the Pets app, because what we want to do is add a single line that is just going to ignore these warnings. All right, so let's go ahead and add over here in the window group and assign it to nothing. Basically, we're ignoring the variable. So user defaults.standard.set false and UI constraint based layout log unsatisfiable. So we are just making it false. And when you make it false, all of those errors or warnings that you were seeing on the console, they will be all gone. They will be kind of ignored. And now you can see that we can definitely display our featured image, which is just some cute cats. And the next part would be, okay, how do we add more components to it? But another thing that we want to implement is that every single time that we are running the application, it is going through the pet list view model and causing an actual request from the web service, which is fine, right? I mean, the web service is going to perform an actual request and go through the network and give you the JSON. But when you are initially working and just trying to figure out things, it might be more useful that if you're reading the information from a local JSON file so that you can speed up your process. And then when you're happy with it, then you can start targeting the actual network service. So we are going to start with that how we can introduce a local file in the next lecture.